Hello, YouTube. What's up? And welcome back to another video with me, Miss V. I am a math teacher, and today I'm going to be showing you how to prove that vertical angles are congruent, alternate interior angles are congruent, and corresponding angles are congruent using the different rigid motions that I've discussed in my previous videos. So if you're interested in watching something like this and how to prove that these things are congruent and you need to see a visual, you have come to the right place. So I'm just going to go ahead and jump right into it. So first thing we're going to talk about is proving that vertical angles are congruent, okay? So on my screen right now, there are two pairs of vertical angles. We have A and C, which are both in pink, and we have B and D, which are both in light blue, okay? Remember, vertical angles are just angles that are directly across from each other or diagonal from each other, and they are congruent, okay? Now, today, like I said, we're going to discuss the reason why they're congruent. So notice I have two identical copies of the same vertical angles. And the reason why I did that is because I'm about to show you how I can do a specific transformation to the second picture so that it maps onto the first one. So I'm going to go ahead and select these vertical angles over here. And what I'm going to do right now is I'm going to go ahead and rotate the vertical angles, and don't mind the G that's going with it. I'm going to go ahead and rotate them 180 degrees, okay? So basically, I grabbed those two vertical angles and I just shifted the whole picture and rotated it 180 degrees, okay? So now after doing that, notice if I were to grab this picture and put it on top of the other one, now you can see clearly that angle B maps onto angle D. Same thing with D and B. And angle C maps directly onto angle A. So what that means is the reason why vertical angles are congruent, or one rigid motion you can do to prove that they're congruent, is you can rotate your image or rotate your figure 180 degrees. And it doesn't matter whether you go clockwise or counterclockwise, because remember, with 180 degrees, either way, if I start here and I go clockwise, I'm down here. If I go here and I go counterclockwise, I'm over here. And I know that for you guys, it's mirrored. So for you, clockwise would be this way and counterclockwise would be that way. Okay, so it's the opposite for y'all. But you can rotate your figure 180 degrees and it maps onto each other. Another transformation you can do is a reflection, and I'm going to see if I can actually flip this figure over, because I don't think that I can. No, I don't think I can flip this figure. Let's see, convert. Nope. Yeah, so we can't flip the figure, but if I went ahead and I grabbed the vertical angles and I basically just like flipped them onto each other or flipped it over one of these diagonal lines, you'll see that they end up mapping right on top of each other as well. So you can also reflect over a diagonal or reflect over line AB. And I'll label line AB right here, A and B, or C, D. Okay, same thing. So those are for vertical angles. You can do the same thing for alternate interior angles and for corresponding angles. I'm going to go ahead and do corresponding angles first because that one is a little bit easier to visualize. And if you don't know what any of these angles that I'm talking about are, then go ahead and take a look at one of my previous videos. It should be labeled parallel lines cut by a transversal, terms, definition, something like that. I'll link it up here. I'll link it up here for you guys so you can watch that video. If you have no idea what these different angles I'm talking about are, you can go ahead and watch that video where I go over all of the terms and definitions for you guys, okay? All right, so here we have two parallel lines being cut by a transversal. Okay, and I'm going to draw another set right over here. Try and make it look exactly the same, or at least very similar. Yeah, that should be okay. Okay. So when we have two parallel lines cut by a transversal, remember, let's say this is angle A. That is angle A. This angle over here, B, that is my corresponding angle for that, okay? So again, A and B, okay? So with corresponding angles, it's a little bit easier to visualize the transformation that you do here. Because think about vertical angles. I had mentioned in the previous video where it's basically this angle being slid down or translated, okay? So essentially the transformation that you're going to do to map angle A onto angle B, and I know it's not exactly the same, but what you're basically going to do is you're just going to grab that first angle A and you're going to translate it along the directed line segment CD. So this line segment from C to D over here, you're going to grab angle A and just slide it or translate it down here. And that's how you map angle A onto angle B, which proves that corresponding angles are also congruent. Because remember, rigid motions do not change the size or shape of your figure. So if I do a rigid motion on an angle, I'm not changing the size or shape of the angle, which means that they're the same exact measure, okay? So translate along directed, and a directed line segment is just a line segment that has a direction. So if I say directed line segment CD, I'm just saying, okay, I'm going from C to D. That's pretty much it, okay? Directed line segment CD. All right, and then the last one we're going to look at is alternate interior angles. Alternate interior angles. Again, those are also congruent. And let's draw the picture again. I think I'm just going to copy it for this one so that I'm not drawing it like 45 times. Here we go. Arrows, arrows, and arrow. Okay. And by the way, for those of you who want to know, this app that I use is called GoodNotes, and I love it. It's really great for taking notes for any class. You can do it at a high school level, college level. I got this app when I was in college, and I had just gotten my iPad because one of my friends had recommended it to me, so I just went ahead and I got it. It's awesome. It works really well. All right, so now we're looking at alternate interior angles. So let's use this angle A and this angle B over here. So A and B. So basically here I'm trying to prove that angles A and B are congruent using some kind of rigid motion. And again, I'm going to go ahead and rotate 180, drag it, boom, right there, okay? So if you rotate your figure 180 degrees, that is one way to prove that they are congruent. So rotate figure, and by figure, I mean the two parallel lines being cut by the transversal. That's the figure, 180 degrees, okay? That is one way to prove that they're congruent. You could also possibly do, let's see, if angle A is here, if you reflect it about that line CD, it'll go from here to over here and then translate it downwards. That's another way to do that. You can do a reflection and then a translation. But usually for these rigid motions, we just want to prove that they're congruent by just using one rigid motion, not more than one at a time, or a sequence of transformations, okay? But that is all that I have for y'all for today. So today's video was basically about proving that vertical angles, corresponding angles, and alternate interior angles are congruent by using different rigid motions. So I hope that this video was helpful to you guys. And I think I've mentioned it before, but if this was difficult for you to visualize, you can go ahead and use the GeoGebra app or geogebra.org on your computer and just look up different activities. The good thing about GeoGebra is that you can play around with it yourself and move stuff around yourself. So definitely a suggestion for y'all. But other than that, if you enjoyed this video, go ahead and give me a thumbs up and click on that subscribe button. Just click it. And I will see you guys in my next video. Have a good one, y'all. Bye.